Okay. So we talked about greenhouse gases, climate, and biodiversity. There's a few core case studies that you can read through, but that's not what I'm going to talk about right now. All right, so what factors influence climate? In other words, the climate that you have is caused by what things, right? So you have solar energy, rotation of the earth, air and water movement, atmosphere, and surface features. Like if you're living closer to the ocean, right, you have a different climate than if you're inland. Weather is temperature, precipitation, wind speed, cloud cover. It's from hours to days. So you have the weather report for the next 5 days. It gives you an idea of what's happening, but it's for daily. Climate is the general conditions over decades and longer. Now, that climate change is due to our greenhouse gases increasing. So, why do we care so much about the greenhouse gases increasing? Because now it's like having this big blanket over the earth that we can't turn off. It's like having an electrical blanket. It's a good thing to have some greenhouse gases. Why? Because they keep the heat, they trap the heat. In the absence of all these greenhouse gases, we would freeze to death at night when the sun went down. But because there are greenhouse gases, the heat is trapped, and it's a good thing. But now we have too much of that heat being trapped, and so for that reason, the concern is, what do we do about decreasing the greenhouse gases? Yes?
Do greenhouse gases mean like the UV radiation from the sun can hit us more?
Greenhouse gases mean that the heat that is produced, so once the sun's rays hit the earth, right, there's a certain amount of heat. Where does that heat go for the most part? It just dissipates, right? But when you have this greenhouse gas, it's like a surrounding shield around the earth that's causing the heat to stay in, which is a good thing as long as it's not too much. Okay, so it's the too much we're worried about.
Wait, so just to understand, the heat can get into the earth by the sun, but it doesn't really escape, or?
It does escape.
Just, okay.
Most of it escapes. Some of it stays on because of the greenhouse gases. Now, because there are so many greenhouse gases, more of it stays on.
But it still comes in?
It's going to come in, otherwise we're going to freeze to death, right? It has to be. That's sun's rays coming in. So looking at this, what do you see? These are the generalized map of Earth's current climate zones. So it gives you an idea of the currents, and the temperature has to do with the environment that it's in. So when you have the red arrows, those are warm ocean currents, and then the blue ones are the cold. Okay? So you have many different climates, which we'll see. Ocean currents we're going to look at and talk about because they play a pretty big role in the way things are. And last year we were supposed to have El Nino. We don't know what happened to it. But there was supposed to be a pretty, big El Nino where we got a lot of rain. But and then when they were looking at the ocean currents, they saw warm water was moving, and all the indications for the El Nino were there. It just didn't show up.
So would it
Let's say,
is it overdue now, or is it just not?
I don't think it's coming around. But then who knows, right? Mother Nature has a mind of its own.
Could it just be overdue?
Yeah. All
It's
right.
like a late assignment.
So,
We'll take
the
it.
sun's rays, they hit at the direct angle at the equator. That's what makes the equator so hot, right? The more angled they are, the less heat they're giving. So that's why the polar caps are freezing, whereas equator is nice and that's where your tropical areas are.
Okay, if the sun is
I feel like the weather leaf.
if the sun is so big in comparison to the Earth, why isn't most of it just not angled? Because, do you know what I mean? In relation, if this is the sun and the Earth is like this big, shouldn't most of it be direct? It's not like we're getting a lot of stuff coming.
But the Earth is tilted.
There was something called La Nina.
Yeah, La Nina is a smaller version of El Nino.
So the strong La Nina forms, here's how it was like the U.S.
Yeah, but I don't think that brings in as much heat as El Nino. I think El Nino is...
El Nino referred to like Southern California, or is it all over the United States?
El Nino is global. thing that
It's a
can
global
happen.
phenomenon.
So
Yeah.
if you look at El Nino, you wouldn't find anything specific to El Nino returning to Southern California, right?
We've had an El Nino before.
But like,
Did it just skip over to Southern California? Did it have another?
I don't
place?
know. I don't know what happened last year. Okay, so low pressure, high pressure. Pressure is defined as force per unit area. Air molecules exert a certain amount of force, and there's a certain amount of air pressure, atmospheric pressure, that is measured daily, and that is really dependent upon elevation. Higher up you go, lower pressure you have, okay, because you have less air molecules. Warm air rises, cold air sinks.
Rushes in.
And that's why if you live in a 2-story house, your upstairs is always warmer than downstairs, because warm air rises, it's less dense. Cold air is denser, it sinks. And that's how the convection currents work.
So, how does it start? Because once the hot air goes to the top and the cold air goes to the bottom, isn't it just there?
And then it heats up on the bottom,
Oh, so there has to be a
Cools.
heat source on the bottom.
and then that's how you end up with convection
But
currents.
then when you need heat source on the bottom.
Well, you need something to heat it up, yes.
So it's
Okay.
all it's.
So,
It's
convection.
better for your bill to heat the bottom of your house and hope it rises to the top. Like if you have a heater on the bottom floor and on the top,
Right,
would it make more sense to turn on the bottom heater than the top?
yes. Exactly. So, what's a convection? It's
convection-
current of heat. Okay, so it's basically exactly what is happening here. Hot rises and cools, so that's condensation and precipitation happens there. When it's cool and dry air, it sinks. Okay, because it's more dense. Denser objects or denser materials sink. Less dense rises. Okay, and that's how your convection ovens work as well.
Right.
Nice.
Now, that idea connects deep and shallow ocean currents all together globally. Okay? The red is the warm and the blue is the cold.
Why is it that some of them are hotter than others? Currents.
Depends on the area. Just like we
Is it like
talked about it.
geothermal or
Next to the, well, a certain part could come, that's part of the ocean heats up from the bottom.
so the water is one of those areas.
All right, El Nino.
Okay.
It has to do with location. But anything that's in the tropical areas is all warm water.
You know what the
So deep ocean is cold regardless of where it is, except for the vents.
Okay.
So the deep vents is heat that's coming from the mantle.
So it could just
That
be,
heats up that area though, not much more than that.
All right.
So the circulation really has to do with just the temperature of the water because of its location.
You know where the Mariana Trench is? Or what it is?
Deep ocean trench.
The deepest point of Earth's ocean.
Alright, El Nino happens every few years, so we hope. Prevailing winds in the tropical Pacific Ocean change direction and it affects much of Earth's weather for about 1 to 2 years. So if we got the El Nino, Australia was going to get a drought,
Chocolate.
but that didn't happen.
Chocolate goose.
No. El Nino. We're going to talk about El Chapo.
Can we talk about Emperor Cusco
Okay?
and his new groove?
So, El Nino versus normal conditions, you can see the difference. And that's what was supposed to happen, but it didn't. Why? Who knows? And so El Nino would cause droughts in certain areas. So El Nino is not just rain all across globally. El Nino just changes weather conditions.
Why isn't Los Angeles
Okay?
highlighted?
Because we didn't get it.
Unusually warm periods would be the red regions, and then the blue areas are the unusually high rainfall. We don't really get unusually high rainfall.
Blue off the coast of California.
But we didn't get much of it.
So it's a lie?
Alright, gases keep the earth habitable, and these are the greenhouse gases, so water vapor, carbon dioxide, methane gas, and oxide of nitrogen. But then human enhanced global warming is the problem. Oh, we're out of time.